This video lesson is all about proving properties of parallel lines cut by a transversal. If we have line M, which is parallel to line N, meaning these two lines will never meet even though we will extend them from left to right, is cut by a transversal line P, we will create 8 angles. We have the angle 1, 2, 3, 4, 5, 6, 7, and 8. Let's have the first postulate, which is the corresponding angles postulate. It states that if two parallel lines cut by a transversal, then the corresponding angles are congruent. Using this figure, we have line A, which is parallel to line B and cut by a transversal T. We have these angles. We need to find the corresponding angles. Let's start with angle 1. Angle 1 is congruent to angle 3. So as you can see, angle 1 is at the top of line A and angle 3 is at the top of line B. And they are both at the left side of the transversal. So angle 1 and angle 3 are congruent because they are corresponding. How about angle 2? Angle 2 is congruent to angle 4 because they have the same position and the same side. Next, we have angle 5. Angle 5 is congruent to angle 7. And then the last one, we have angle 6, which is congruent to angle 8. So these are the 4 pairs of corresponding angles which are congruent. Next, let's have the alternate interior angles theorem. If two parallel lines cut by a transversal, then the alternate interior angles are congruent. When we say alternate, it means one angle is located at the left side and the other one is located on the right side. And they are both inside the two parallel lines. So let's have proof 1 to prove this theorem. Given M is parallel to N, so that is the symbol for parallel. And then transversal P cuts M and N. We will be using this figure. We need to prove that angle 2 is congruent to angle 3. Using this two-column proof, we will provide the missing information. For the first statement, we have M is parallel to N. And then the reason is obviously the word given. For the second reason, we have vertical angles are congruent. Looking at the figure, which angles are vertical? So we have angle 1 is congruent to angle 2 because they are vertical angles. And then for the third statement, we have angle 1 is congruent to angle 3. For what reason? What is the relationship of angle 1 to angle 3? They are congruent because they are corresponding angles. So our reason will be corresponding angles are congruent. And then for the last one, we have transitive property. If A is equals to B and B is equals to C, then A is equals to C. So I want you to look at statement 2 and 3. Angle 1 is repeated, so our final statement will be angle 2 is congruent to angle 3. Looking at the figure, we have angle 2 and angle 3. They are alternate interior angles. We already proved that the alternate interior angles are congruent. Next, we have alternate exterior angles theorem. If two parallel lines cut by a transversal, then the alternate exterior angles are congruent. So we have angles in different side of the transversal, and they are at the exterior, meaning outside the two parallel lines. Let's have proof number 2. Given M is parallel to N, transversal P cuts M and N. Using this figure, we need to prove that angle 1 is congruent to angle 3. We will provide the missing information in this two-column proof. The first reason is given. So what will be the statement? M is parallel to N. For the second statement, we have angle 2 is congruent to angle 3. What is the relationship of angle 2 and angle 3? Our reason here is corresponding angles are congruent because angle 2 and angle 3 are corresponding angles. How about for the third statement? We have angle 1 is congruent to angle 2. What is the relationship between the two angles? They are vertical angles, so they are congruent. Our reason is vertical angles are congruent. For the last statement, we have angle 1 is congruent to angle 3, which is our proof. And our reason will be the transitive property. So looking at the figure, we have angle 1 and angle 3. They are alternate exterior angles, so they are congruent. Proof 2, prove that the alternate exterior angles are also congruent. Next, we have same side exterior angles theorem. If two parallel lines cut by a transversal, then the same side exterior angles are supplementary. So when we say same side, the two angles are located on the same side, and then exterior, meaning outside of the parallel lines, and then they are supplementary. What do we mean by supplementary? It means that the sum of the two angles is equals to 180 degrees. We will prove this theorem using proof number 3. Given Q is parallel to R, transversal P cuts Q and R. Using this figure, we need to prove that angle 1 and angle 2 are supplementary. We need to complete this table. The first reason is given. So our first statement is Q is parallel to R. For the second reason, we have definition of linear pair. What do we mean by linear pair? I want you to look at the figure. Which angles create a straight angle which is 180 degrees? Those angles are angle 1 and angle 3. They form a linear pair. So looking at the figure, they are beside each other and then they form straight angle. For the third reason, we have if two angles form a linear pair, then the angles are supplementary. Meaning, if these two angles are linear pair, they are also supplementary. For the third statement, we will have angle 1 and angle 3 are supplementary. Next, we have the continuation. For the fourth statement, if they are supplementary, meaning if we add the measurement of angle 1 and angle 3, their sum is 180 degrees. What will be the reason? The reason will be definition of supplementary angles. And then for the fifth statement, we have angle 2 is congruent to angle 3. Looking at the figure, we have angle 2 and angle 3. What is their relationship? They are congruent because they are alternate exterior angles. So here, we will apply the alternate exterior angles theorem. For the last set of statement and reason, we have the sixth reason, which is definition of congruent angles. If angle 2 and angle 3 are congruent, we can also say that the measurement of angle 2 is equals to the measurement of angle 3. For the next reason, substitution property. What do we mean by substitution property? Just like in playing basketball, player 1 can substitute player 2 in the game. So using the fourth statement, measurement of angle 1 plus the measurement of angle 3 is 180 degrees. We will use this statement, but since the measurement of angle 2 is equals to the measurement of angle 3, therefore, we can replace the measurement of angle 3 to be the measurement of angle 2. So our seventh statement will be the measurement of angle 1 plus the measurement of angle 2 is equals to 180 degrees. For the last reason, we have if the sum of two angles is 180 degrees, meaning they are supplementary. What will be our last statement? The last statement is angle 1 and angle 2 are supplementary because based on the seventh statement, their sum is 180 degrees. So now we already proved that angle 1 plus angle 2 is equals to 180 degrees, or they are supplementary. Next, we have the same side interior angles. If two parallel lines cut by a transversal, then the same side interior angles are supplementary. This one is almost the same with the same side exterior, but here the angles are located inside the parallel lines. We will prove this one using proof number 4. Given Q is parallel to R, transversal P cuts Q and R. Using this figure, we need to prove that angle 1 and angle 3 are supplementary. So in our two-column proof, the first statement is Q is parallel to R. What will be the reason? The reason is given. For the second statement, we have angle 2 and angle 3 form a linear pair. Our reason will be definition of linear pair. If angle 2 and angle 3 are a linear pair, it also means that they are supplementary. The reason here is if two angles form a linear pair, then the angles are supplementary. For the next reason, we have definition of supplementary angles. What is the definition of supplementary angles? If angle 2 and angle 3 are supplementary, meaning the measurement of angle 2 plus the measurement of angle 3 is equals to 180 degrees. For the fifth reason, we have alternate interior angles theorem. In the figure, what are the alternate interior angles? We have angle 1 and angle 2. If they are alternate interior angles, meaning they are congruent. So we will have angle 1 is congruent to angle 2. For the sixth reason, we have definition of congruent angles. If angle 1 is congruent to angle 2, we can also say that the measurement of angle 1 is equal to the measurement of angle 2. For the last part, our seventh statement is the measurement of angle 1 plus the measurement of angle 3 is 180 degrees. So why is this our seventh statement? Let's go back with the fourth and sixth statement. In the fourth statement, it says that the measurement of angle 2 plus the measurement of angle 3 is 180 degrees. For the sixth statement, the measurement of angle 1 is equals to the measurement of angle 2. So here, as you can observe, in the seventh reason, the difference between 4 and 7 is that the measurement of angle 2 is replaced by the measurement of angle 1. So what property is being applied here? We have the substitution property. For the last statement, since if we add the measurement of angle 1 and the measurement of angle 3, which is equals to 180 degrees, we can now prove that angle 1 and angle 3 are supplementary. So looking at the figure, we have angle 1 and angle 3. These two angles are same side interior angles, so they are supplementary. Next, look in this figure. The measurement of angle 1 is 120 degrees. Find the measure of angle 2. What do you think is the relationship between angle 1 and angle 2? They are corresponding angles. Since they are corresponding angles, we can say that the measurement of angle 2 is also 120 degrees since they are congruent. Next, using the same given, let's find the measure of angle 3. Angle 1 and angle 3 are alternate exterior angles. If they are alternate exterior angles, what is the measurement of angle 3? The measurement of angle 3 is also 120 degrees, since according to alternate exterior angles theorem, these angles are also congruent. Another one. Let us find the value of x. In this figure, we have angle 1 is 3x, angle 3 is 105 degrees. First, you need to find the relationship between the two angles. Angle 1 and angle 3 are alternate interior angles. If they are alternate interior angles, we can say that the angle 1 is congruent to angle 3. And then, using the definition of congruent angles, the measurement of angle 1 is equals to the measurement of angle 3 so that we can solve the value for x here. Next, we will just substitute. The measurement of angle 1 is 3x equals the measurement of angle 3, which is 105. In order for us to get the value of x, we need to divide both sides by 3. 3x divided by 3, that is x, and then 105 divided by 3, that is 35. Meaning, here, the value of x is 35 degrees. Next, using this figure, we have angle 1, 140 degrees, angle 2 is 4y, and angle 3 is 2x plus 10. First, we need to find for the value of x. We will be using here angle 1 and angle 3 so that we can find the value of x. So we will cover or disregard line 2. So now, what is the relationship between angle 1 and angle 3? Angle 1 and angle 3 are same side interior angles. If they are same side interior angles, meaning they are supplementary. So we will add the measurement of angle 1 plus the measurement of angle 3, which is equals to 180 degrees. The measurement of angle 1 is 140 plus the measurement of angle 3, which is 2x plus 10, equals 180. First, we need to combine the constant terms. We have 140 plus 10, which is 150, and then copy plus 2x equals 180. Next, we will use the left and the right side. We will leave the term with variables on the left side and the constant on the right side. Let us start with 150. Do we need to transpose 150? Yes, so it will become negative 150. Next, we have 2x. Do we need to transpose 2x? No, so we will just copy 2x. And then 180, we will just copy positive 180. And then we will just simplify. We have 2x, negative 150 plus 180, unlike sign minus, copy the sign of the bigger number. The answer is 30. Now we need to divide both sides by 2 to get the value of x. 2x divided by 2, that is x, equals 30 divided by 2, that is 15. So the value of x here is 15. Next, using the same figure, we will find for the value of y. So here we will disregard line 3. What is the relationship between angle 1 and angle 2? Also, same side interior angles, and they are supplementary. So if we add the measurement of angle 1 plus the measurement of angle 2, the total is 180 degrees. The measurement of angle 1 is 140 plus the measurement of angle 2 is 4y, which is 180. We will use the left and the right side. Let's start with 140. Should we transpose 140? Yes. So positive 140 will become negative 140. Next, we have 4y. Do we need to transpose 4y? No, so we will just copy. And then we have 180. It is at the correct position, so we will just also copy. Next, we will copy 4y equals negative 140 plus 180. Unlike sign minus, copy the sign of the bigger number, which is 40. And then we will divide both sides by 4 to get the value of y. 4y divided by 4, that is y, which is equals to 40 divided by 4, that is 10. So the value of y here is 10. That's it. That's how to prove the properties about parallel lines cut by transversal.